Welcome to section 2.4, biconditional statements and definitions. Our objective today is to write and analyze biconditional statements. So when you combine a conditional statement and its converse, remember the flippy version, so PQ, QP, you create a biconditional statement. The way this works is you're going to have the word if and only if instead of if and then. So you're going to take out your if and then, and you're going to just write in the middle, if and only if. There's different ways of writing it. So you could have this double arrow there, meaning it could go either way, because it could be the front way, it could be the converse way. Or you could write out if and only if. Or if you want to go the shorthand, you can just write if with an extra F there. These all mean if and only if. So we're going to write the conditional statement. So we have here a biconditional. We're going to write the conditional statement and we're going to write the converse. So we need to first figure out what our P and our Q are. And you see that they're already on the screen there. But our starter is always our hypothesis, our P. So an angle is obtuse, P. We're going to take out our if and only if. That's gone. Its measure is greater than 90 degrees and less than 180. So that would be my Q. And now we're going to create a conditional statement. And all we have to do here is add an if and a then. I do believe I have it on that screen here. Here we go. Okay. So if an angle is obtuse, and we see it right here. If an angle is obtuse, then, and you don't have to say an angle again. You can say it if you want, which they did here. Then its measure is greater than 90 and less than 180. Now write the converse, where you flip them. So if an angle's measure is greater than 90 and less than 180, then it's obtuse. See, we just flip them. That's all we did. Okay, let's practice with the next one. This time they didn't write the words if and only if. They used the arrows. It means the same thing. So we're going to do this. We're going to find our P, which is this, and our Q, which is this. And then we're going to write our conditional statement first, our regular one. We're going to start with if. So if a solution is neutral, what do you think our then is going to be? Then its pH is 7. Okay, that one is easier. Now we need to work on the converse. We're going to flip them, okay? So we want to keep our noun where it is. So if a solution's pH, pH is 7. See, I'm just going to take this bit and move it up. Then what? Then it's neutral. Okay, don't forget to keep your noun at the beginning, so that way we know from the start what we're talking about. If you start off with if it, then I don't know what it is. You need to identify what it is. In this case, it's a solution. Okay, and here's the breakdown of it. We did very good. Okay, this one. This time we had the conditional. They want us to write the converse and the biconditional. So if the date is July 4th, P, then it is Independence Day. That's my Q. So the converse would be flipping it, okay? So if it is Independence Day, then the date is July 4th. Okay. The biconditional, you could take the original and take out the if and the then, just those two words, the if and the then, and put in the middle if and only if. If you want to write this or if you want to write this, they all mean the same thing. Okay, you choose what you want to write. It means the same thing. So in order for a biconditional statement to be true, the original and the converse both have to be true. Okay, so if you say the original statement and then you flip them and it's wrong, it's not true anymore, like the cat example before in our previous lesson, then the whole thing's not true. It's not a biconditional anymore. A biconditional statement needs to work both ways, and it needs to be true both ways. So let's check this one out. This one's mathematical. Okay, so if we start at the left and go right, we'll start there first. So if y equals -5, okay, we're just assuming y is -5. Does y squared equal 25? Well, let's check it. So y equals -5. Now let's plug it in for y and see if it equals 25. Oh, that checks out because -5 squared is 25. Perfect. Okay, so that's true. Now we have to check the converse. We have to go the other way. So we're going to start out with y squared equals 25. So if y squared equals 25, does y always equal -5? Well, if we were finding the square root of each one, we could potentially get -5. But there's one other thing you could get in this instance. Think of the simplest way to do this. Square root both sides. Square root of 25 is also 5. So this could be 5 squared, and you could get 25. Or it could be -5 squared and get 25. So since there's two possible outcomes in this instance, it's not true. It's false. Okay, and because of that one counterexample for the entire thing is false. So this biconditional is not true. It's false. And that was my counterexample right there. Because y could be 5 when y squared equals 25. So in geometry, biconditional statements are used to write definitions. So when you think of a word, there's usually only one definition that describes it and you think of the word. Okay, so if I'm thinking of an animal that roars and has a mane and is a type of large cat, you instantly probably think of a lion. Now that would be a good definition. Now if I just said a large cat, you could be thinking of a cheetah, you could be thinking of a tiger. That would not be a good definition. Okay, so you want to think of the definition and the item as a pair. They need to work both ways. That would be a biconditional statement. So in mathematical terms, we have polygons. So here are some just definitions for us to have. So a polygon is defined as a closed plane figure formed by 3 or more line segments. Okay, so any figures, any of these are polygons. Now these on the right hand side are not polygons because this one has a curve, this one has a little excess, this one is enclosed, this one is actually 2 polygons, it's got kind of a bow tie shape going on, and this one is 3-dimensional. Okay, so it needs to be 2-dimensional, a plane, and it needs to be formed by 3 or more lines. Now of those polygons, if it has 3 sides, it's a triangle. If it has 4, it's a quadrilateral. Think of quad as the motorbikes that you ride. It's got 4 wheels. Quad means 4. So quadrilateral is a 4-sided polygon. Triangle, tricycle, it's 3 wheels, 3-sided polygon. Okay, so definitions can be reversible. You can go from definition to word, word to definition. They need to be going both ways. So in this, we're going to determine whether it's a good well, we already know it's a biconditional, but this is a good definition for each one. We're going to write it as a biconditional. Okay, so we're going to start with what it is. So what is it? It looks like it's a polygon. Okay, so or we could say a figure if you want. A figure, a shape. A figure is a pentagon. Now, what's our keywords for biconditional? The if and only if. So a figure is a pentagon, and that was my Q. This is my P and my Q. There we go. That might help you out. So P, Q. We want to write it as is, and we're just going to write the if and only if in the middle. So a figure is a pentagon, if and only if, and we're going to use our arrows this time. It is a 5-sided polygon. There we go. So a figure is a pentagon, if and only if it is a 5-sided polygon. Perfect. Perfect. I got all the bits in there. And it flows. You want to be able to say it and it makes sense. Grammatically, you want it to make sense, okay? So for this next one, a right angle measures 90 degrees. A right angle is our P. Measures 90 degrees is our Q. Okay, so you want it to flow. And we're going to use, let's use IFF this time just to show you a different way of writing the if and only if. So what are we talking about here? looks like we're talking about an angle. So an angle is what? An angle is right. If and only if, I'll use my IFF this time, it, because we're talking about the angle, measures 90 degrees. Perfect. So an angle is right if and only if it measures 90 degrees. All we did here was we just added some keywords here, we manipulated the words a little bit to make it work grammatically, and we added the IFF in the middle. Good job. And that is the end of that one.